this video. In this video I'm going to start simple linear regression, and in the upcoming videos I will discuss how to implement simple linear regression in Python, and also how to start the multiple linear regression and all the things related to the multiple linear regression. So this entire course is going to be on based on regression analysis itself, and we are going to work on a lot of projects, a lot of data sets. So let's this video start. Before starting the simple linear regression, let me discuss what is this supervised learning. So supervised learning actually means that you want to you will have a data, and in the data set you will have two variables in the simple linear regression, especially x and y. So in simple linear regression, the supervised learning means that you will have a y variable and a x variable. In general, supervised learning algorithm are those algorithms which will have a data set, and there are a lot of variables which will be like x1, x2, something like that, and there will be a variable called y, which is also called a response variable. So it means that based on this x and y, you have to model or you have to make a model which will be able to predict y given the x. So this is called supervised learning, where you will be given the this response variable, but there are certain algorithms where this y is not available, like the clustering or the unsupervised method. Those are generally called unsupervised method. So mainly supervised learning is the those algorithms where you will get the x and y all together, and you have to make a model such that if you are giving a new x, it will be able to predict y based on whatever the observations it has seen previously. So like this data, you can see that you will have a two data, or year of experience and salary. So year of experience, based on the year of experience, certain salary is there, and we have been given this data. So we will try to fit a simple linear regression model on this, and then we will see if we will try to give a new year of experience, then what is the salary predicted by the model. We'll also see how to model the performance of a linear regression model, and also how to make predictions and just visualize the results in the afterward. So we'll start all these things in this particular video. So simple linear regressions, what is a simple linear regression? Simple linear regression is a linear model. So it try to attempt the it model the relationship between two variables by fitting a linear equation. So you can see that this is the one of the examples. So you can see that this is in two dimensions. So maybe this is x and this is y. Okay, and you can see that when you plot x and y, you actually see a linear relationship between the variables. So like the red line that you are actually seeing, this may be one of the best fitted line which is able to approximate the behavior of all the points. Linear regression is a method or algorithm that you try to model the relationship between two variables by or more than two variables. It can be more than two variables, especially if you are talking about multiple linear regression. So in simple linear regression, you will find only x and y, single x and single y. But in multiple linear regression, you will have x1, x2, a lot of variables till xp, and then you will have a y variable. So based on all these particular features for a particular rows, you will have a single y. So this is called multiple linear regression. But in simple linear regression, you will have only two variables. Linear regression is mainly used in banking domain. So a lot of companies in banking or finance or this kind of things actually use linear regression, and a lot of new research are also based on the linear regression. So I will try to bring some papers which actually is based on deep learning but utilizes linear regression in the backend to modify the result. So that is also one of the application of linear regression, and it is one of the most popular classical ML algorithm that is widely used still in the industry. Form of linear regression, which is y is equal to a plus bx. So this is called a linear equation because we know that when we will plot this line in two variables, you will get this is x and this is y. You will get some line of this kind. Okay. So here in the term of regression, we will just consider it a line, but in term of regression, x is called explanatory variable, or it is also called predictors. Okay, and y is called a response dependent variable, or it is also called a response variable, or there are a lot of names associated with x and y, and the x is also called sometime independent variable. So let me explain you why this particular x and y are called independent and dependent. So you can see that y actually depends on some form of x, like a plus bx. So if you want to get y, what you can do, you can just give an x and just give this value of a and b, you can get the y. So y is dependent on x, or maybe there are a lot of variables, let's say x2, x3. So maybe it's also depend on x2 and x3. But this x is independent. The form of x is independent. X is not like x is depending on some other variables or some other thing, but x is independent, observed, or you can say that this data has been collected, and this x is independent. It's not dependent on y or any other variable. That is why the name is called y. X is called explanatory because it can explain itself, or it is used to explain y. And y is called dependent because it's depending upon x. And similarly, you can just find the meaning of each and every keywords by just giving that y is depending upon x and x is just independent variable. Now, if we'll just put b is equal to 0, then y is equal to a, and this is called intercept. So this is called intercept, and b is called the slope of the line. But this is just the general interpretation of simple simple line linear equation. But in the term of regression, what this particular things means, we'll actually see soon. Moving to fitting the model, like generally I have seen most of the YouTube channels and most of the tutorial, what they do, they will give you a data set, and what they will try to do, they will try to fit a model. But before fitting a model, it is important to understand the assumptions of linear regression. I know like this assumptions is very basic, and this is actually fundamental of the linear regression. So let's start discussing the assumptions. The first is called linearity. So linear regression is applicable because we assume that the x and y, there is some linear relationship between x and y. There can be just approximate linear relationship, not so much linear, but yeah, there can be a linear line which can approximate the data well. So there should be some kind of linear relationship between x and y. Now coming to the homoscedasticity, I know the word is difficult, but it means that the variance of residual is the same for any value of x. I know I have not defined the residual yet, but yeah, we will soon discuss what is the residual and what is the variance means. Now we have the independence. Independence means that the residuals should be independent. So like whenever you calculate the residuals, sometimes it may happen that the residuals are having serial correlation. Now you have the normality. Normality assumes that the residual of the models are normally distributed. So if epsilon is the residual, then it should be normally distributed with mean 0 and variance sigma square. And let's say this sigma square should be constant for each and every residual. So that is what is covered in the homoscedasticity, this independence and the normality. So simple linear regression. So how to actually proceed with the simple linear regression? So simple linear regressions, you will have a plus bx plus epsilon. This is very general form, and this epsilon actually follow normal 0 comma sigma square. So this is one of the assumptions. And what you need to do, you just need to find a and b to like make predictions for the future x or maybe some new x. So you need to estimate a and b. So a and b are actually called the regression coefficient, and this particular thing is used for predicting y based on the x. Now, how do you estimate a and b based on the data? So one of the popular method actually used to calculate the coefficient of regression. So how do you calculate the method of least square? So just understand the fundamental behind the method of least square. So let's say you are having the data at x and y. Just try to understand this in two domain, because obviously we are understanding the simple linear regression. So let's understand that you have a data and you plotted the data. So this is how your data looks like. Okay, what is this method of least? So let's understand what is the method of least square. So once you plot the data, what you can see that this is the blue plot, this is the blue plot, and let's suppose this black line is the best fitted line. So obviously each and every point will not lie in the lie on the line itself. So maybe it may happen that there is some point that lies on the line, but not all the points will lie on the line. So what you have to do, you have to calculate the error. So let's say this is the y1. Okay, let's denote it's y1, this is y2, this is y3, and similarly y4 and y5. So like for this y1, the predicted will be on this line. Okay, so this is y1 hat. So let's represent hat because this is the estimated or maybe the predicted by the model. This is y2 hat. So what you need to do, you need to calculate the error. So error actually means that error is equal to the real one minus the predicted one. So this is generally the error. Okay, so let's represent it by I, because this is for all the errors. And now what you need to do, you need to square the errors. Okay, and need to sum all the errors, like starting from y from 1 to, let's say there are n point, and this is called the error. So what is the method of least square? Now if you just have this particular sum of square of error, this is not error, it is sum of a square of error, then it means that the method of least square means that it calculates the best fitting line by observing the data by minimizing. So this is the quantity that you need to minimize, the sum of a square of the vertical deviation. So whatever the error that we have understand now, this is called sum of a square of vertical deviation. So this vertical deviation means that if this particular point is there, then just take it mirror point on the line itself, and this is the vertical deviation of this particular point, and just calculate this difference and just find all those difference and minimize this point, minimize this quantity, and while minimizing you will get the value of a and b. So now we know that y hat is going to be equal to a hat plus b hat x. So this is generally the prediction of a linear regression model, that like we write as this way. So this hat is called predicted y, this a hat is called estimated a, b hat is called estimated b, and when you will put this particular things here, what you will get, you will get a nice equation that you can solve. This formula is going to be b is equal to summation of xi minus x bar y minus y bar divided by x minus x square the whole square. So this is the particular summation that you get while you will solve the a and b. So now there is certain assumptions or certain fact about the regression model. The first fact is that if you will take x bar and y bar, which is equal to your mean of the x bar, whatever the data you have got, and mean of y data, it is going to lie on the best fitted regression line itself. So let's say this is particular x bar and y bar. So this is one of the fact behind the regression model. If you are going to take the mean of x bar and y bar, this particular point x bar comma y bar is going to lie on the best fitted regression line. So like you can say that okay, what we can get based on that. So what you can do, you can now write your y hat is equal to a hat plus b hat x. Now what you can do, just replace x bar and y bar by x and y equal to y bar is equal to a hat plus b hat x bar. Now b hat you have already estimated from your minimizing the quantity that we discussed earlier. So here a bar is a hat is going to be y bar minus b x bar or capital X bar. So this is going to be your a hat, and this is what the formula is there. So now we come to a point where we have calculated a and b, and now we want to understand like, okay, what is the interpretation of this coefficient? So just understand what is the interpretation of this coefficient using this particular formula. So we have, let's say we have estimated a regression is equal to minus 1.33 okay, it's not 33.8 and plus 115.91 x. Okay, so this is a constant term and this is the obviously the slope. So let's say we put x is equal to 0. So x is equal to 0, if we put, we get y is equal to minus 133.18. So interpretation of this constant term is that it represents the value of y when the x is 0, or this is, you can say that the mean response value of y, mean response value of y. Now what is this particular x? So we can also understand what is the x, what is the interpretation of this particular estimated coefficient b. So to understand the estimated coefficient of b, what we can do, we know that y is equal to 133.18, and what we will do, we will just increase the x by x plus 1. So if you just increase the x by x plus 1, what will happen? Your quantity, this particular quantity is going to get increased, and how much the y is going to get increased? Y is equal to 1 minus 133.18 plus 115.91 x plus 115.91. So the interpretation of this particular regression coefficient is that it is the amount it get, like we have written that in the simple term, it represents the mean change in the response variable for one unit change in the predictor variable. So this particular coefficient represent what is going to be the change in the y when x is going to get increased by 1. So this is the main thing behind the interpretation of a regression coefficient. So this is often asked in the interview. In fact, each and every slide that I've discussed, starting from the assumptions, what is the linear method of least square, this particular interpretation, what is the value of a and b for the simple linear regression, these all are generally asked in the data science interviews, and this is how we need to interpret the coefficient. This coefficient is actually the amount that y get increased when x is increased by 1, or if it's minus, then the amount it get decreased. Now let's move to the model evaluation regression. So there are three main metrics that we use for the model evaluation regression. First is called R square, adjusted R square. So these are two different things that we'll discuss. Okay. Then we have mean square error or root mean square error. This is generally the root of this mean square error. And then you have mean absolute error. So we'll try to see the formula of all these things in the next module. But for now, let's start and code the linear regression using the data set that we discussed, the salary and experience data. Thanks for watching.